In this video, we will do a harder U-substitution example. So we have the integral of x to the 5 over square root of 1 plus x squared dx. Okay, so for this one, I'm going to try letting u be equal to 1 plus x squared, the thing inside of the square root. So when we take the derivative, du is going to be 2x, and I got to make sure to write that dx. And looking at this, I might notice, wait, I don't see du in my integral, even off by a constant multiple, because du is 2x. And in my integral, I see x to the 5, and the powers just don't match. So that's true, but still, I'm going to stick with it and see what happens. So if I isolate dx, we get du over 2x equals dx. So now let's plug in. So we'll get integral of x to the 5 over the bottom becomes square root of u, and dx is du over 2x. So if I simplify, I can pull out the 1/2 and get the integral. And I get a little bit of cancellation because x to the 5 over x is x to the 4. So we get x to the 4 over square root of u du. So we mentioned in a previous video that if we do a u-sub, and after doing it, if I still have my old variable in there a little bit lingering, like I do here, x to the 4, we can try using our u-sub again. So let's try to use u equals 1 plus x squared again to sub in for those lingering x's. So here's how I'm going to do that. Let's isolate the x squared. So we get u minus 1 equals x squared. So I'm trying to figure out, well, what is x to the 4th? Well, let's square both sides. So if I square both sides, we'll get u minus 1 being squared equals x squared being squared. But this is a power to a power. And when I have that, I multiply the powers. So this is going to be x to the 4th. So now I know that x to the 4th is u minus 1 squared. So I can plug that in for this x to the 4th. So let's do that in the next step. I'll get 1/2 my integral of u minus 1 squared over square root of u du. Okay, now I have my integral completely in terms of u. Okay, so we have 1/2 times the integral. And to handle this, let's expand u minus 1 squared. So that'll give us u squared minus 2u plus 1 over the square root of u du. Okay, so we have 1/2 times this integral. And now we can split up this fraction into pieces as u squared over, and let me rewrite square root of u as u to the 1/2, and then minus 2u over u to the 1/2, and then finally plus 1 over u to the 1/2 du. Okay, now this is nice because we can simplify each of these, and I'll get 1/2 integral. So u squared over u to the 1/2. I use the exponent property where we subtract the powers, and that'll give me u to the 3/2. And then minus, next term is 2 u to the 1/2. And with the last term, that becomes u to the negative 1/2 when I bring that u to the 1/2 up. Okay, du. Now we're ready to take this antiderivative. So we'll get the 1/2 in front of everything. I'm going to put a big bracket for everything that's about to go inside. Okay, for u to the 3/2, I do some reverse power rule, and I'll get u to the 5/2. And when I divide by 5/2, that's the same as multiplying by 2/5 by the reciprocal. All right, next term, I get minus 2 times. I do u to the 3/2 when I add 1 to the power. And then when I divide by 3/2, that's the same as multiplying by 2/3. All right, and for this last term, again, I add 1 to the power to get u to the 1/2, positive 1/2. And instead of dividing by 1/2, I'm going to just go ahead and simplify, multiply by the reciprocal, which is 2. Okay, and this is a general antiderivative, so I got to write my plus c. All right, now I'm going to do two things. I'm going to distribute this 1/2 to all of these terms, and I'm going to sub back in for what u was. So 1/2 times this first term will give me 1/5. And now let's plug back in for u. What was u? It was 1 plus x squared. So we'll get 1 plus x squared to the 5/2 power. Distributing it to the next term, it'll cancel this 2 and leave me with minus 2/3. And then times 1 plus x squared to the 3/2. And distributing it to the last term, it'll cancel that 2 and give me plus u to the 1/2, which becomes 1 plus x squared to the 1/2. And then we got that plus c. And that is our answer. Ooh, let me write that better. Alrighty, so that is our answer.